This is section 6.3. Let's do the last two questions at the same time, numbers 9 and 10. Number 9 says, find a z such that 76% of the normal curve lies to the right of z. Now I want 76% of the area lying to the right of z. So could it be this one? Well, first of all, it's 76%. That's more than 50%. So you know that the z is going to have to be to the left of 0. Because at 50%, the z would be 0. And I've got more than that to the right. This looks like a possibility. This can't be because it's to the left. This is less than 50% of the area. This is to the left. It's got to be this one up here. Now, let's do this by inverse norm. Now we need to put in the area. The area always goes by the programming of the calculator from negative infinity to the left. Now this is the picture that we have. We don't want to put in the area being 0.76 because that's the area to the right. So what we have is that area right there is 0.76. The calculator will only take the area to the left, which is 1 minus 0.76, which is 0.24. All right, so we're going to put in 0.24 for our area. It's the z-curve, so the mean is 0, standard deviation 1. Let's paste and compute. So I came up with negative 0.7063. Now it's a z-score, so we're going to go to 2 decimal places. 1, 2. I'm going to round that up, right? So how about negative 0.71? So up here at the top, I'm up here at the very top left. Let's write our answer as negative 0.71. Negative 0.71. Now, lastly, problem 10. Find the z-value such that 90% of the standard normal curve lies between these two numbers. All right, so it has to be 90% between these two numbers. Now, I want negative z and positive z, so it looks like it's symmetric. Now, what about this one? Looks possible, right? Because I'm between negative z and positive z. This has only one tail. This is not the area between, and this is only one tail. I think we should go with that. That looks like it could be 90% of the area between those two numbers. So let's go here. Now to get this z-value, right, what I'm trying to get now is, what is that z-value? And then by symmetry, I'll get that one. All right, so it's a z-value, so I'm going to use inverse norm. All right, so let's go get inverse norm. And inverse norm, when you ask for that, it's asking for area, mu, and sigma. So what area are we going to use here? What area do you think we should use? Right, this area in the middle here is, what did it say? 0.90. That's 0.90. So what should we use? Remember how the calculator is programmed. It's programmed to read from the area, to pick up the area from negative infinity out to your number. Now, if this is 0.90, how much do you have left? How much area is, that doesn't show up very well. How much area is here and here? Right, if this is 0.90, what's left is 0.10. And we're cutting it in half, right? So this is going to be 0.05. So let's put our area in here. So the area is going to be 0.05. It's z-curve, so the mean is 0, standard deviation is 1. Let's paste and compute. So when I computed, I got negative 1.6448 and so on. But if I round to 2 decimal places, I'm going to get, well, now I'm just going to get 1.64. Negative 1.64. So that means that this number right here, that's the negative 1.64. But by symmetry, I'm going to have another one over here, and that's going to be, right, there's negative 1.64. This is positive 1.64. Now the problem just asks us this. All right, here's the problem. Find the z-value such that 90% lies between negative z and z. Now, if I report z as this number, I mean, both of them would work. But if I report it as 1.64, then negative z is the negative 1.64, positive z is the 1.64. But it should work the other way too. If I reported negative 1.64 for z, then negative z would be negative 1.64. It still works.